Today on The Explainer, recrystallization. It's how chemists take a messy mix and get pure, perfect crystals. See, many chemical reactions are messy. So how do you isolate the one thing you actually want? Take aspirin. The raw product is mixed with some irritating leftovers. Yeah, you don't want that. So here's the plan. We'll look at the problem, the solution, the process, and how to get the good stuff. And that clever solution is called recrystallization. It's a brilliant way to separate the good from the bad. The whole idea banks on something simple. Stuff dissolves when it's hot, but not when it's cold. You just need a solvent that grabs your compound when hot, then lets go as things cool down. A perfect solvent has a few key traits. It can't react with your stuff, and it should be easy to remove. Okay, let's get into the process. First up, what about the gunk that won't even dissolve in hot liquid? That's where hot filtration comes in. The fluted paper gives more surface area to filter out that junk fast.
But here's the really important catch. You have to keep everything hot the whole time.
Because if it cools down, your pure stuff crystallizes right there, trapping all the impurities with it. All right, with that junk gone, it's time to form our pure crystals. This is where the magic happens. The key here is you have to cool the solution down slowly. No rushing this part. It's like building with Legos. Go slow and only the right pieces fit into that perfect crystal structure. But what if the crystals are just stubborn? Sometimes they just won't form. So what do? Well, chemists have a few tricks, like scratching the glass to give the crystals a place to start growing. Okay, we've got pure crystals sitting in cold liquid. Now, how do we actually get them out? For this, we use vacuum filtration. It uses suction to quickly pull the liquid away from our solid crystals.
It's way faster than just letting it drip, and it gives the crystals a head start on drying.
For a final touch, a quick rinse with ice-cold solvent cleans off any lingering residue. And that's the journey, from a messy mixture all the way to a pure crystalline solid. Makes you think, right? Purity often needs a clever separation process, and that's not just true in chemistry.